All right, here we go. We're recording. Do not get him batteries. He wants to act like a big kid. He can get his own big kid stuff. Hypothesis testing is right over here. Third part. Let's just review the first two parts quickly. That's too many words for you. All right. First, we have a claim. That claim involves three letters. Claim also involves a number. Okay? So, the null hypothesis. Which symbol is used in the null hypothesis? One of those three, the population proportion, the population mean, or the standard deviation. And then equals. There you go. Equals. What about the alternative hypothesis? Same three letters. Greater than, less than, or not equal to. And we have our letter right there. So that means it's going to be either a right-tailed test, a left-tailed test, or a two-tailed test. Okay? We also talked about how to find a z-score if you're given alpha and if you're not given alpha. Okay? Talked about how to find those. So, that's what we talked about. We also talked about rejecting or failing to reject the null hypothesis. Today, we're going to take our first steps in doing that. We're going to talk about the p-value of a test. We're going to talk about the conclusion of a test. And we're going to talk about z-scores. Okay? All very exciting, fun stuff. Yeah, here we go. All right. Okay. So we've done this, the null, the alternative, the given claim, and we've done symbolic form. Test statistic, p hat, x bar, chi-squared, variance, all that stuff. Critical values, z-scores, t-scores, chi-squared again. Chi-squared probably shouldn't be up there. For this should be the s. Okay. Left and right. P-value is what we're going to talk about now. So we're working our way down the list. Feel very good about this. You ready? Good. Hypothesis is rejected if the p-value is very small, such as 0.05. The p-value is the area of the shaded region. Not small, but capital P. That stands for probability. If the probability is low, it's not going to happen. If the probability of the test statistic is high, it's going to happen. We looked up on one of our websites, first year I did this, and Sam and Alex and all of them came up with this off of YouTube, and we actually put it on there. If the P is low, the null must go. I didn't remember the second part, because if the null goes, then it's going to happen. If it doesn't go, then it's not going to happen. But they use this a lot. I remember students actually muttering this on their tests when they were doing problems. If the P is low, the null must go. And what do you consider low? Right up here. 0.05 is low. Remember, we said anything past 0.05 is considered unusual. So unusual is things that go. I think I'll move this over here. See what happens. What's he doing? Oh. Nice. I'll put it right here. Let's see if there's any change in the tone. All right. So, there's a, obviously we're talking about h sub 0. Now, why is that important? Well, because this is h sub 0, this is h sub 1. If we have the following statement and we say the null must go, that means the alternative hypothesis is probably going to be true, or we're rejecting the null, which means the alternative is going to be true. If we don't, if we fail to reject this, then we're not saying anything. We're not saying that the null is true or that the alternative is true. Okay? So that's how it's set up. We're not supporting anything, we're just testing. So, about time to get some problems. We already know that about the p-value, left tail, right tail, two tails. We already talked about that, right? With the non-equal sign being the two tails. And the greater than sign is the right tail. Left is the less than. Okay, we've already talked about that quite a bit. That's a flow chart. We're not really flowchart type people. That's more like for programmers and things like that. We more or less just jump into the problem and try to solve it. But the p-value is equal to the area for probability. All right, last thing, capital P different from small p. Capital P stands for probability, small b population proportion or percent. 1%. I think we're ready to get started. We got two things to do. I'll talk about type 1 and type 2 error, p-values, and statistics. Okay. So, hopefully we're ready. Yes, we are. This, if your test statistic is in this region, we're going to reject the null. If it's between this region, we will fail to reject. You'll actually use these words in your conclusion. I reject the null, I fail to reject. This should look exactly like the pictures you made for your last test, with the shaded regions, with your z-scores, t-scores, things like that. The only thing we're adding is areas that's in bounds and out of bounds. Smaller probability, greater probability. Okay? So, we don't have any numbers yet, but that means a two-tailed test. So, oh, don't forget. The p-value in this case would be equal to the area on the left plus the area on the right. This is the area on the left. This is the area on the right. It would be equal to those two. You add them together, that'd be your p-value. Not too difficult. Don't worry too good. Go on. All right. On the one tail, this would be the area. That would be the p-value. The area. Just out of curiosity, what's the probability of everything under the curve? What's the area of everything under the curve? If I shaded everything in underneath the curve, it's 1. Okay? You're talking probability. 1 means 100%. Okay. So that's where our complements come in, 1 minus alpha, things like that. Right tail, obviously, he's going to be right over there. Okay, that's it for definitions for a while until we get to type 1 and type 2 error. We're going to do some calculations. I can. Okay, so not equal to is two tails. So if your alternative hypothesis has that, your picture's going to look like this. And then you're going to have words go on your picture, and your answer will take about half to 3/4 of the page. Your solution to a problem will be half to 3/4 of a page. For homework, you'll get 1, maybe 2 problems. Yeah, those are big kid problems. Okay? All right. You guys look at me the same? I did. It's great. Just it was awesome. All right. See, now I can't. Now I look forward to the afternoon. Yeah, that's just great. Okay. We've already talked about that. That's known as a conclusion, not your final conclusion. This is what you draw from the test. This isn't your final answer. Okay? Yeah, forget the final answer in a minute. Yeah, we already talked about that. Here we go. Use the information to find the p-value. So this is where, if you don't have a calculator, you turn your book to page 753. If you have a calculator, I don't even know if you know how to use it. So, this is 0.05 is my significance level. It says the test statistic is z equals 2.50. So we're going to draw what kind of picture? Bell-shaped curve. Where's 2.50 going to go? Right here. So you're going to look up 2.50 in your table. You're going to go down 2.5. You're going to go over to the O column, 0.0. Tell me what number that is right there. 0.9938. So now the question is, what's wrong? I'm going to get to that. So now the question is, what is the area right here if the whole thing is 1? Right, so what is 1 minus that? 0.0062. Okay. So the p-value is equal to 0.0062. If you have a calculator, remember, if you're trying to find the area between two numbers, you have 2.50 and 1E99. That'd be a normal CDF calculation. 2.5, 1E99. If not, you can use page 752 and 753 if you don't have a calculator to find the same thing. Normal CDF, 2.5, 1E99. Remember, it was left bound, right bound. You should have gotten the same thing as 0.062. Okay? So, that is the p-value. The conclusion is, how does this compare to 0.05? Larger or less? Less. So I will reject the null hypothesis. That's the answer to the question. You found the p-value and you stated the conclusion. You didn't state the final conclusion, just the conclusion. This is only one part of a 5-part solution. We haven't gone to the biggest part yet. Now, let me refresh Dalton's memory. You had to calculate your own z-score from yesterday, correct? So, once you get your z-score, then you go find your p-value, then you go reject or fail to reject, and then you go write your final conclusion after you've written your conclusion. That's not the final conclusion, that's just a conclusion. We don't have enough information to finish it, but we're going to get to it today. No. Okay. Well, let's try one more right here. Here you go. You're right. Good thing you don't have a lot of plans tonight. Here we go. Use this significance level and state the conclusion about the null hypothesis. So, look on your book. Page 273. I'm sorry, page 572. Because it's a negative z-score. Yep, that'll work. What do you got for me? Negative 2.95. P-value, point what? There we go. You see how this sign is right here? That means a left-tailed test. The p-value is different than the population proportion. If you're going to do normal CDF, it'd be negative 1E99, comma, negative 2.95. Normal CDF. So, is this larger or smaller than 0.05? Smaller, so what are we going to do? Reject the null hypothesis.
So we're using 0. Oh, it's such a.
Yep. That's coming up shortly. So, reject the null hypothesis. Okay? So either use your normal CDF or use your textbook. Yes?
So, if it corresponds with the alternative, then you're rejecting it, right? Because like in this case, 0.0016 is less than the 0.777.
No. This is a population proportion. It has nothing to do with the test statistic. That number comes from the claim. They're claiming like 78% of the population wears seat belts. No, we're not using that at all. That does not factor into our calculation. Okay? We use the relationship to come up with our area of rejection for our statistic. Okay, but that doesn't go into our calculation yet. Ready? This next one is going to be two-tailed. Z equals negative 0.55. Your picture will look like this. Just out of curiosity, what's going to be the other one over here?
0.55.
Very good, 0.55. Don't laugh at him. Tell me what this area is right here. 0.2912. What's the other one going to be? Close. The other shaded region. Yeah, that means that's from the area this way. I want to know to the right. You can take 1 minus. 0.2, I'll bet you. 9. Yeah, you can. It's symmetric. It's the same thing.
Oh.
See the same numbers? Same area. However, the p-value is not 0.2912. What is it? So how do you get 0.5824? Yeah, remember, the p-value is both regions. Is this less than, equal to, or greater than 0.05? Greater than, so you failed to reject. So we've done 3 problems in less than 10 minutes. We aren't there yet. I don't know. We have tomorrow yet to do also. Moving on. I want you to worry about one thing. Batteries. Moving on. Batteries. Here we go. Fail to reject the null hypothesis. There's our conclusion. You ready, Dalton? Good. Here we go. What's next on our list of things to do? The final conclusion. No. Just watch this for a moment. Watch both examples. Do not write anything down.
All right.
Because you will see how similar it is, and then you won't find it so difficult. So here's the claim. The percentage of one-time U.S. airline flights is less than 75%. Somebody went through the whole test, okay, and they came up with reject the null. Okay? In this percentage of one-time U.S. airline flights, what do you think the null hypothesis would be? P, mu, or sigma? P. And do you think it'd be an equal sign? 0.75. Okay. This one, H sub 1, would be what? P is less than 0.75. So watch very carefully. You are rejecting the null hypothesis. Okay? Makes sense? So, watch the wording of this. There is sufficient evidence to support the claim that the percentage of on-time U.S. airline flights is less than 75%. Take a look at the word and take a look at what your test has done. Since you've thrown out one statement, what statement is left? There is sufficient evidence to support the fact that the percentage of U.S. is less than 75%. That's what you write. Okay? So does that make sense? Remember, you're saying in the test, only one of two outcomes is possible, not both. Okay? Ready, Allison? Here goes the other one. And that won't take you hours upon hours to do. Okay? The wording is going to be the same. This part is going to be identical every time you reject the null. Does that make sense? So what I want you to do is, I want you to write down, reject the null, and this first sentence. That will be your standard go-to answer. Just like, I love it, when players are interviewed in high school sports, and they mimic, or they reiterate what the coaches have been telling them all week. We played hard, we controlled the tempo, there's a team effort. That's not what you want to say, but that's what you're going to say, because that's what you've heard so many times.
What do you players want to say?
They will say it was all me. I did it. I've worked hard for this moment. I deserve it. Give me more. Give me money. Give me
Is that what you
pay.
wanna say, Nick?
Give me food.
I don't get you.
Give me the day off.
Give me
Give me
food.
more.
We used to have talks in the locker room about what to say should an interview occur after this game.
What would you say? What would you tell them to say?
I'd say you always respect the opponent. You always compliment your team. You look forward to the next game. We worked very hard for this moment. We're working hard for next year. They're going to play college ball, like my seniors did.
Like my sleep.
Oh, yeah, you are.
You're always
Okay.
right?
Ready? Here we go. This one. The null hypothesis and the alternative hypothesis. Percentage of Americans, now don't write this down again, just watch for a moment. The percentage of Americans who know their credit score is equal to 20%. What's the null? P equals 0.20. What's the alternative? P is not equal to 0.20. Okay? Now, fail to reject the null. You're not rejecting the alternative. You're not rejecting the null. Very good. You're catching on. There is not sufficient evidence to warrant the rejection of the claim that the percentage of Americans who know their score. So, those are the wordings for both responses and outcomes. That is known as your final conclusion. The first part of the sentence does not change. There is not sufficient evidence to warrant rejection of the claim. You're not endorsing the alternative, but you're not rejecting it either. Okay? So that's how you write a final conclusion. Don't forget, between the beginning and the end, you found your z-score, you found your p-value, you checked your numbers, and now you've gotten to this point. Okay? Now we've talked about this test, there's one more thing to talk about. The errors, or the possible errors in your test, and as some people in this room know, you never admit when you're wrong. you simply say it's a type 1 or type 2 error. So, here is a type 1 error. Watch first, and then write this down. You're given two hypotheses. A type 1 is the mistake of rejecting the null when it's actually true. It was actually true and you rejected it. That's a type 1 error. Okay? So go ahead and write it down now what a type 1 error is. They're really into an alphabet. It never really comes up in elementary statistics. That's later on. Well, I wouldn't say that because I don't want you missing questions on the test just because I didn't know anything about it. But see, that's in red now because we got burned on that in the chapter test. Nobody knew what a type 1 or 2 was for that time. Cruise our own by.
Was that your first time teaching it?
Oh, yeah.
How many people were in stats last year?
12?
Really?
12 to 14.
How many do you have this year?
How many do I have?
Yeah.
More than 12 or 15. Here's a type 2 error. Watch first. The type 2 error is a mistake of failing to reject a null when it's actually false. Okay? That means I'm not rejecting anything and the null is actually false. Okay? Example of that, mistake of failing to reject the null when it's actually false. That'd be like failing to reject the null. Try to think of a courtroom situation in which you convict or not convict. Try to think of an argument. Heads, tails. You conclude it's not heads. I don't know. Maybe there's a thing right here. The correct decision is the null is false, and we decide to reject the null. So that's the right way of doing it. A type 1 error is when you decide to reject it and it's actually true. Okay? Remember, this is conditional probability. This means you've already made a mistake, and that's the error you're off by. Okay, so how far were you off in your calculations? Why did you decide to reject the null? You know, what were your numbers? Then, when we fail to reject the null, that's when it's actually true. Okay. So a type 1 error would be that you convicted a person who was innocent. Let's say they were innocent and they were guilty. And you found them guilty. Okay? So that's type 1 error. Type 2 is when you find them innocent, and they are actually innocent, but you found them guilty. It kind of hurts when you stop and think about it for a while. That's why we don't think about people. The percentage of Americans who believe that life exists on Earth is equal to 20%. So here we go.
You left that
What?
part out. Freaked me out.
What?
You didn't say only.
Yeah, that was really confused.
Life exists on Earth.
Well,
Oh, only on Earth. Gotcha. P equals 0.2. H sub 1
We got that.
not equal to 0.2. Let me get my type 1 and type 2 error set up. So, type 1, I'll throw this out, but it's actually true. Okay? Because you can calculate how far off you were. How far off from your mistake were you? It's a conditional probability. Here, a type 2 is you fail to reject it, and it is actually false.
percentage of Americans who believe that life exists only on Earth is equal to 20%. That means 8 out of 10 you believe there's life on other planets or systems.
I believe it.
You can't dump though. Either it is or it isn't. Okay. Put that in words. Yeah, good luck. That's your job, not mine. There you go. That's all we'll do. All right, there's a list of things to do. That's what is at the OTD, and we'll check it off. All right.
Not me.
Oh,
What I do?
there we go. So what's our assignment for today?
27 to 45 by 3.
27 through 45 by 3. That is about 3 hours worth of work. And I'm giving you 20 minutes to get started.